Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to EV Components Review. On the loving bench of teardowns is the Tronic 250 controller. You can go look out on the internet and you can find the little FOCer, or a little Fokker, F-O-C-E-R, and the board inside it is the exact same one as in here. Same developer, same engineer, everything's the same. Only thing that's different is the case. And quite frankly, this is a nicer case in my opinion. This is the typical Tronic way of doing things, you know, lots of attention to detail and just pretty much everywhere. And they have in this case as well, including easy access to the USB-C port, you know, through this nice little milled out hole in the base piece of aluminum. As is common for a lot of your smaller vest stuff, or almost all vest stuff, is they are not waterproof. And so, you know, you need to put this someplace where it's not going to be exposed to water, like inside some kind of a waterproof box is probably best. Because once you get inside, you'll understand why. But as you can see, there's a large opening here, you know, for USB-C, there's that one. And over here too, you can move the phase wires one direction or the other, depending on what works best for you. And the battery wires the same way. You've got open holes around them. So water incursion is absolutely going to happen. And this is pretty typical for anything that's VESC. The only exceptions that I know of right now is the Tronic 750 and the EBMX X9000. Otherwise, everything else that I can think of that's VESC is all completely open and exposed like this and not watertight in any way. The cover is held down by 4 M3 screws like those. And so that's going to be very securely mounted, and it's got a lip around it right here. You know, that meets up against this lip right here, so the two pieces meet together nicely and they don't move. It's not just dependent on the screws holding it in place. I like how they do this, and this is true on all the Tronic stuff. All the connector labels and things like that are all inside the shell. They're not like stuck on here where, you know, it kind of like muddies up the looks. How on the inside is really cool, and I can't think of another VESC development project that has that stuff anyplace else other than like on the outside where you see it. But then again, all the rest of them don't actually have like a lid either, with the exception of Tronic. So I think that's probably part of the reason why is nobody else is doing like a completely enclosed controller, and only Tronic is so far. Anyway, one of the things I like about this is that connector right there, which is this one on the board, that is enable. Like all your Flip Sky stuff, or a lot of your Flip Sky stuff, I think most of the Trampa stuff, maybe, no, that's not true. Some of the Trampa stuff does have it, some of it doesn't, I guess. But this is enable right here. So you basically jump 2 wires together on there, and the controller turns on. You open those 2 wires and it turns off. Not having enable, in my opinion, is kind of an oversight. Like I have some Trampa 100 or 75-100 controllers, and they have no enable on them. So the way you turn off the controller is you disconnect them from power, which in my opinion is stupid. just have an enable that turns off the onboard DC to DCs, turns off the CPU. That's the smart way to do it. That way all this stuff, the capacitors and the MOSFETs, they all stay under power all the time. And that's the standard way that everybody does it. So why are some controllers not doing it? I don't know, but they don't. Anyway, I like having an enable. You've got all your standard vest stuff here. This is very typical connector style that you'll find in many, just about all vest stuff. You know, typical JST 2.0 cabling, with some exceptions. So no problems with that really. It's an inexpensive connector that works well. You're going to bring out all of those signal wires through one of these slots, either here or here. There's one detail here that I don't really care for. I'd rather just have the phase wires come out one side and not out the other, but you can see how they're all different lengths, and I would prefer that they're all the same length than 3 like this. Like, to me, this is the right length, and these 2 are too short, and so I'd rather have them this length. And I mentioned that to the owner, Gall, and he goes, yeah, but with them staggered like this, they can't ever short against each other. And I'd have to say, yes, that's true, they can't. But at the same time, when I put my bullet connectors together, and these are 5.5mm bullets, which are very good, I always either wrap a little bit of electrical tape around the joint, or I sleeve the whole thing in heat shrink so that water can't get in and so that they can't pull apart, which they probably won't anyway. But yeah, anyway, if you have two of them that are side by side and they're wrapped like that, there's no way you're going to get a short anyway. So anyway, I'd rather have them all just come out one side and have these cables all be the exact same length rather than, staggered like that. But the reason why that is because they're all the same length here. It's just that when you pull them over to one side or the other, there's going to be two that are shorter than the other one, right? So yeah, that's just a whiny thing about me, I guess. Yeah, nice lid, all CNC machine. This is all 3D machine part. That was all done of a single hunk of aluminum, so that's super cool. All right, let's look inside the box. And actually, I'm just going to pull this one screw out that I still got holding things in. If you do this, you will be replacing your thermal gap filler that's inside. Because, well, it's going to get shredded like it's going to happen here. So I've already pulled this out a couple times. But, yeah, it adheres to the backside of the MOSFETs, like you see here, and as a result, it also tears up on here. This stuff is very heat conductive, but it's also fragile as can be. So yeah, if you do pull up your board, you're going to wreck it, and you're going to need to buy another thermal gap filler sheet to put in there. It's readily available. You can find this stuff on Amazon, eBay, electronic supply stores. It's not hard to find, but yeah, once you do this and it shreds like this and breaks up, you're going to be scraping that one out, which is not hard. A little spooger like this makes it come out pretty easy, but yeah, you're going to be replacing it. That's just how that goes. Anyway, let's look at some of the details here. The engineer that develops this stuff, he's very confident in his low noise buses, and with lower power stuff like this, just a few electrolytics is pretty common. Like if you look at all your Trampa stuff, if you look at like any flip sky things, you'll see a similar amount of capacitance for DC bus filtering, for low frequency filtering. And in fact, these capacitors right here, I saw it on there on one of them. They are like Nichicon, Rubicon, something like that. There it is, Rubicons. Yep. Good brand. I like it. And that's pretty typical for Tronic, that everything is Western components. And in fact, like on the back side, these are all Infineon MOSFETs. Yeah, yeah, can't fault them for that. And I don't know what these little driver chips are yet. I haven't looked up the parts, but bet you anything they're like Infineon or they're TI, something like that. A Western brand, not something Chinese. Probably there's not a Chinese part on here actually, because that's just how Tronic does things. Yeah, here's your Bluetooth module. This right here is your 5-volt DC to DC, and there's its little buck chip for that. Here's the STM32F405. Standard fare of connectors, JST 2.0 stuff that you'll see in just about everything VESC. On the back side here, so this is the inductor for the main DC to DC, and then for the STM32, you have a TMS 111 linear regulator for bringing down that 5 volts down to 3.3 volts for just powering that, and probably also it probably powers the Bluetooth module too, most likely. Yeah, this is a Holy IoT Bluetooth module. Never heard of it before, but yeah, it's supposedly a pretty good one. I haven't looked at it before. I'll have to look that guy up and see what I can find. But anyway, everything here on the top side is pretty straightforward. Lots and lots of integration. This is a multi-layer board. Your battery plus and battery minus wires come in on the bottom, and I'll talk about that in a minute. All your MOSFET legs are right here, and that blob of solder, that is your phase bus, and there's a piece of copper underneath it. So it's a really, really, really short path from the MOSFET legs to here, and it's all reinforced with copper and vias inside and things like that. So yeah, this is not a tortured current path. This is a low side current sensing controller, and here's your three sensors, your 3 shunts for that. And let's flip this thing over. So here's battery minus, and it's probably not showing up on camera, but there is basically a sheet of copper that goes across all of here, and that's all of battery minus, and that of course comes down to all the MOSFETs. And like right here and here and here, there's vias there that come over to the other side for this side of the 3 shunts. And yeah, I don't really see any copper on the top side of the board for battery minus. It's not really needed, not for this kind of amperage. Battery plus, that does have vias all underneath there, and then like that MOSFET leg, and that leg, those have vias on them, that go down to the internal copper plane that's battery plus. So yeah, this is your high side MOSFETs. These are your low side MOSFETs, I'm guessing is how that works. But anyway, yeah, you don't, for this level of stuff, you don't need copper reinforcing. And like back 8000, you know, the ASI controller, they did the same thing. Everything is done with copper planes inside the board for battery plus and battery minus and for the phases, and they're doing the same thing here. This isn't a bad plan, and this does make for a very simple and well-integrated current path right from battery plus and minus to the MOSFETs without the need of extra copper reinforcing, because there's this, you know, that's battery minus right there, and this entire area right here is one big copper sheet, you know, on the surface just for battery minus. So current carrying is pretty darn good, and then battery plus is inside. So again, current carrying is pretty darn good. Can't really ask for more than that, and you don't need, as a result, more copper reinforcing on the surface. And like on the phase bus, you know, between these MOSFETs, the legs are so darn close together, and then there's all those internal vias and things. Yeah, you don't need more than that. And then you flip it over, and then there's your phase bus right there, right at the MOSFET. So again, it's not needed to have more than this. This is gracious plenty as it is. So yeah, that's pretty much everything here. You know, here's your USB-C port. Otherwise, that's it. I will then do a close-up shot on the macro lens with this thing so that we can look at the components more closely. About the only thing I would say that I would want different here is kind of two things. First one is you can see like flux on the board in a lot of places. You know, like, so this is all the connectors. They were probably hand soldered, and of course the capacitors were, and the MOSFETs were. So I would have liked to have seen all that flux cleaned up. Just because a clean board is a good thing. And the other thing is all the small electronics, coat all that stuff in conformal. Like the 750, that's all coated in conformal. My board isn't because it's a repair board. But yeah, normally all this stuff is all coated in conformal. And that way, if water does get in here, it's not going to impact anything. And this is a production unit. So yeah, I would definitely want all that stuff covered in conformal. So that's the only two things I'd really do different here. Otherwise these current paths are nice and tight. Yeah, on a scale of 1 to 10, you know, 10 being a Benjamin Vetter, this is like a 9.5, 9.75. Yeah, so this is still a really good current path. You still have all your ceramic caps right where you need them, things like that. So yeah, this isn't a bad design. It's just that, you know, I would like to see cleanup on here after soldering is done, and then conformal all over everything. And otherwise, leave it as is. Anyway, we will do a close-up on this thing after a while. Hope it helps some folks out. Enjoy. Take care.